Hi, in this session let us discuss about three-phase synchronous generator. Okay, so in most of the domestic and then industrial applications, we know that the type of input to be used is alternating type. This is because if we use the transformers, so we can easily transmit the electrical energy from one circuit to the another circuit. So that is basically the transformers are used to transmit um, the powers over a longer distance. So and hence we can permit to have the generation of the electric power in the remote places. And also in many applications we require the frequency of the AC supply as a constant for the constant power to be generated. Hence the generator because they have to run with the constant speed. Okay, so if the frequency is constant, then the generator can run at the constant speed, so which is called as a synchronous speed, and such generators are called as a synchronous generator. That is the generator which runs at some constant speed. We call them as a synchronous generator. We also call these large generators as an alternators. Okay, so what is the difference between alternator and the DC generator here? Okay, so the armature winding of the synchronous generator is an AC winding. This is the first difference. The armature winding of the synchronous generator is an AC winding, that is, it is connected to produce the AC supply, and the field is connected to the DC supply. Therefore, we don't need the commutator in case of alternator. So, which actually makes the construction simpler than the DC generator. So, I repeat, the first difference between alternator and the DC generator is the armature winding of the synchronous generator is an AC winding. Hence, we don't need the commutator in an alternator. So, it makes the construction simpler compared to the DC generator. And the second difference is, in case of DC generator, the armature winding rotates and the field system is stationary. So whereas in case of synchronous generator, the armature winding which is mounted on the stationary element, we call it as a stator, and the field will be rotating here. Okay, so in case of DC generator, armature winding rotates and the field is stationary, whereas in case of synchronous generator, armature windings will be wounded on the stator, which is static, and the field will be rotating. These two are the major differences. Next, what are the advantages of having the stationary armature? Right. So, as we know that the AC supply has been used in most of the applications. For stationary armature, the large space can be provided in order to accommodate the larger number of conductors and the insulations. The second advantage is it is always better to protect the high voltage winding from the centrifugal forces, which is caused due to the rotation, and hence the high voltage armature is generally kept stationary. The third advantage is it is easy to collect the larger current at high voltage from the stationary member than from a slip ring and then brush assembly. So the voltage which is required to be supplied to the field winding is very low, and hence it can be easily supplied with the help of a slip rings and the brush assembly by keeping it rotating. So the fourth advantage is the problem of sparking at the slip ring. We can avoid it by keeping the magnetic field as rotating, so which is the low voltage circuit. and the high voltage armature as a stationary part. So another advantage is due to the low voltage levels of the field side, the insulation required will be very less, and hence the field systems has very low inertia. So it is always better to rotate the low inertia system than the high inertia system, because the effort which is required to rotate the low inertia system will be less compared to the high inertia system. And the next advantage is the rotating magnetic field will make the overall construction very simpler. And if the field is rotating, so to excite it by the external DC supply, we just need the two slip rings. One is for the positive and another for the negative terminals. So the ventilation arrangement for the high voltage sides, we can improve it if it is kept stationary. So these are all the advantages of having the stationary armature. Okay. Now let us move on the constructional detail of three-phase synchronous generator. So basically it contains two parts, the stator and then a rotor part. Okay. So this is what the structure of the synchronous generator looks like. So let us just discuss separately about the stator and then rotor. Okay, so the stator is a static part and the rotor is a rotating part. So we can say, let us discuss about the stator first. The stator is a stationary armature, and it contains a core, and also it has a slots in order to hold the armature winding. Okay, and the stator cores which uses the laminated construction. This laminated construction basically keeps the minimum eddy current losses. And the choice of material for the stator is steel, in order to keep the hysteresis loss minimum. The entire core is fabricated in a frame, so which is made up of the steel plate. Okay, and as I said, the core has a slot in the periphery, so which can accommodate the armature conductors. We call them as a field windings. So basically the frame doesn't carry any flux, but it just provides the mechanical support to the core. And also the ventilation is maintained well with the help of holes caused in the frame. So let me just recall one more time. Stator is the static part or the stationary armature. It has got core and the slot in the periphery. In periphery we can have the armature winding, so which is nothing but conductors. The stator core uses the laminated construction, which helps in keeping the eddy current loss minimal, and also the choice of material which can be used is steel, which keeps the hysteresis loss minimum. And the entire core is fabricated in a frame which is made up of a steel plate. This frame structure will not carry any flux, but it just provides the mechanical support. So this is what the section of alternator stator looks like. Okay, it has got the stator core, and so these are the slots where we have kept the conductors, copper conductors here. Okay, and the slot with an insulation lining around it. Okay, next moving on to the rotor. It is a rotating part. So we will find the two types of rotor which are to be used in an alternator. The first type is salient pole type or projected pole type rotor, and the second type is smooth cylindrical type or the non-salient type rotor. So let us take the salient pole or the projected pole type rotor. Okay, this is what the structure of salient pole type rotor looks like. Okay, right? Here we can observe the poles are projected out, therefore we have given the name as a projected pole type rotor. So this is the DC supply, and these are the field windings which are mounted on the poles, and these are the slip rings. Okay, so as I said, we also call the salient pole type rotor as a projected pole type because the poles are projected out from the rotor surface, and these poles are made up of the thick steel laminations. So we can observe that the poles have been given the specific shape here. So this is to have the large diameter with a small axial length, and this type of rotors are mechanically very weak, and generally they are preferred for the low speed alternators, generally 125 rpm to 500 rpm alternator prefers salient pole type rotor. Okay, so this type of rotors will be having the large diameter and small axial length. They are mechanically very weak, the poles are projected out, and they prefer for the low speed alternators. Next is smooth cylindrical type rotor. Okay, so this is what the smooth cylindrical type rotor looks like. So we can just observe this is a cylindrical in shape, and it has got also got the slots on the periphery. So the unslotted portion will act as a pole here. So you can observe this portion is unslotted, this portion is unslotted, this portion is unslotted, and also this portion is unslotted. Okay, so they are acting as a poles, and in the slots we have placed the conductors. So whatever we can just observe here, they are nothing but conductors. Okay, so here we can observe that the rotor will contains this solid steel cylinder, and it has got a slot. So these are nothing but the slots, and unslotted portion, as I said, it acts like a pole. So this type of rotor will be having a small diameter and the large axial length, and here the this type of rotors are very strong mechanically, and they are preferred for the high speed alternators, so generally which can run from nearly 1500 to 3000 rpm. Thank you.